All right, let's get right into it. Welcome to this explainer. Today, we're talking about an absolute game changer for your math exams, a tool that is basically a mathematical superpower. I'm talking about the graphic display calculator, or GDC. If you've ever stared blankly at a massive algebraic equation, erased a hand-drawn graph for the third time, and just wished you could see what the math was actually doing, you are in the right place. We're going to break down exactly how to use this incredible device to turn confusing, abstract functions into crystal clear visual insights. It's not just about crunching numbers, it's about actually seeing the math. Let's unlock this superpower together.
Here's our game plan for today. First, visualizing graph transformations. Second, plotting with your GDC. Third, finding roots and zeros. Fourth, locating the y-intercept. Fifth, tracking down maxima and minima. And finally, creating tables of values.
Starting off with Section 1, Visualizing Graph Transformations. Okay, so before we let the calculator do all the work, we kind of need to know what's actually happening conceptually, right? Take translations. It sounds fancy, but it literally just means sliding the graph around without changing its actual shape. For example, if you have your standard base function, y equals f of x, and you tweak it to y equals f of x plus 2 inside the parentheses, what does it do? Well, it actually picks up every single point on that graph and shifts it 2 units horizontally to the left. The shape is exactly the same, but its position on the grid just slides over. Once you get this manual rule in your head, the GDC just becomes your way to instantly verify that you nailed the shift. Moving right along to Section 2, Plotting with your GDC. All right, now let's actually put this tool to work. Imagine sitting in an exam and coming face to face with this absolute beast of a function. F of x equals negative x cubed plus 9x squared minus 24x plus 16. Trying to accurately sketch a cubic function like that by hand? No way. That's a massive time sink. But with your GDC, you just switch over to graphing mode, carefully punch in that exact equation line by line, and boom, the calculator handles the heavy lifting instantly. But, and this is a really critical detail, sometimes you hit graph and you just get a totally blank screen, or maybe just a weird, unhelpful straight line. Don't panic, it's usually just your viewing window. You've got to tell the calculator exactly where to look, how far left, right, up and down to set the axes. It's exactly like adjusting the zoom and focus on a camera lens, so the entire shape actually fits in the frame. All right, Section 3, Finding Roots and Zeros. So what are we actually looking for here? You'll hear the terms zeros and roots tossed around constantly, and they mean the exact same thing. We are talking about the precise coordinates where our curve crashes right through the horizontal x-axis. In a lot of high-stakes word problems, finding these roots is literally the entire point. It's how you find the solution to the equation. If you're rocking a Casio calculator, extracting these roots is super smooth. Once your graph is beautifully displayed on screen, you just open up the GSolve menu and hit Root. The calculator will immediately snap to the very first intersection and display its exact coordinate. And since a wild curve like our cubic function can cross that axis multiple times, you just tap the directional pad to hop right over to any other roots. Easy as that. Now, if you're on a Texas Instruments calculator, it's a slightly different dance, but just as powerful. You'll jump into the Calc menu and pick the 0 option. Now, it's going to ask you to essentially trap the root. You move your cursor just a bit to the left of where the graph crosses the axis, that's your left bound, and hit enter. Then go just a bit to the right, your right bound, and hit enter again. The GDC zooms in on that bounded slice of the graph and locks onto the coordinate. Quick heads up though, our sources note that sometimes the TI gives you a ridiculously close approximation instead of a perfectly clean whole number. So just keep an eye out for that. Which brings us to Section 4, Locating the y-intercept. We've conquered the horizontal axis, so let's look vertically to find the y-intercept. Finding where your graph crosses the vertical y-axis is actually pretty easy to do in your head. Because the y-axis sits exactly where x equals 0, you just swap in a 0 for all your x's. In that huge cubic equation we used earlier, all those x terms just evaporate, and you're left with simply y equals 16. But if you want to be completely sure or just save your brain power, your GDC completely automates this using the GSolve or Calc menus. For example, on a Texas Instruments model, you just pop back into that Calc menu. You find the tool that lets you evaluate the function for a specific x value, literally type the number 0, and hit enter. The calculator instantly drops a pin right on the y-axis and hands you the exact coordinate. It takes maybe 2 seconds. Okay, Section 5, Finding Maxima and Minima. All right, we've got the roots, we've got the intercepts, but what about the turning points, the extremes? In math speak, we call these local maxima and minima. In normal speak, these are just the peaks and the dips of your graph. You've got the graph swooping down into a valley, that's your local minimum. And then it climbs up to form a hill, that's your local maximum. These vertices represent the absolute lowest and highest values the function hits within that specific local area. To track down the exact coordinates of these peaks and dips on your TI calculator, it's essentially the exact same trick we used for finding roots. Go to the Calc menu, pick either minimum or maximum, and do that left-bound, right-bound thing again. If you want the peak, put a marker on the left of the hill, one on the right, and the calculator scans that slice to find the absolute highest point. Same exact process for the lowest point of a dip. If you're tackling an exam question about maximizing profit or finding the lowest point of a trajectory, this is exactly how you pinpoint it. Finally, Section 6, Creating Tables of Values. For our last trick, we're going to flip from looking at a smooth visual curve back to raw, hard data. Because sometimes you don't just want the big picture, you need exact numbers. We can literally tell the GDC, hey, take this function and spit out the exact f of x value, the y value, for x equals -1, 0, 1, 2, all the way up to 5. And doing this is super intuitive no matter what brand you're using. On a Casio, you just jump to the dedicated table menu, plug in your settings, like where you want the table to start and end and the step size between numbers, and bam, display the results. On Texas Instruments, you go to the table setup, enter those exact same properties, and let it calculate. It transforms a complex curve into a perfectly neat, organized spreadsheet in seconds. And that wraps up our explainer for today. We've seen how the GDC is basically a legal cheat code. It effortlessly translates massive functions, plots complex curves, zeroes in on exact roots and intercepts, maps out the highest peaks and lowest dips, and builds precise data tables without breaking a sweat. It takes all that tedious, frustrating friction completely out of the equation. So I'll leave you with this thought. If a few quick button presses can instantly tame a wild cubic function, just imagine the sheer amount of time and stress this little machine can save you when the clock is ticking down in your final exam. Are you ready to stop calculating everything by hand and let the GDC do the heavy lifting? Keep exploring, and thanks for joining me today.